We're
started.
super excited that you guys are joining us. Sorry, what's that, Ben?
We're just starting now.
Okay. Welcome, everybody. Thank you for joining us. This is our third webinar. The topic today is do's and don'ts of commercial design. And I want to start out by thanking all of you who are here and participating, hoping that this brings some value and that we're not just wasting your time, because I don't want to do that at all. We're grateful for our customers who are on here and those suppliers that we've been working with and that you guys have been working with. We're super grateful for you guys to be joining us today. And I also want to start out by letting you know that we don't believe in any way that we are experts on the topic of commercial designs. And the point of this webinar is really more of a discussion and to see what you guys have experienced in the industry, give you what our opinions and thoughts are, and then maybe, see if there's something of value that everybody can get out of this meeting. So we'll share with what we've learned in our course and our experience, and then we'll open up for questions a little bit later. And by all means, I'm going to open up my chat. If anybody has any questions, by all means, please drop that into the chat and we'll try to address them. Ben has been really good at monitoring these webinars. We have today on the call is Catherine Kelso, who is working with Whistling Consulting, and she's our Director of Commercial Design. And she has had her own business and has experience doing commercial designs herself. She has a background in electrical engineering and has just recently sat for the PE exam to become an electrical engineer. Super grateful for her to be on our team and the knowledge that she brings to our team. We have Heath, who has been on most of these calls with us, and he has 10 years experience in structural engineering design, been working with us for a couple years now. And has a great deal of knowledge when it comes to these commercial roofs as well. And then we have Greg Elvestad, who, as you all pretty much should know, he's got 30 years experience in the industry. He's worked 25 years for a power company, has been instrumental in developing processes here at Whistling Consulting and other companies before he's even joined us. And we're super grateful to have him on our team as well. He's been working with us for a couple years as well, licensed in all 50 states, including Puerto Rico, Virgin Islands, and soon to be Canada. And then you've got myself that I've been working in industry for around 30 years as well, heavy into the solar realm over the past 12 years, I would have to say. Instrumental at building out some engineering departments internally for some very large solar companies, and been kind of trying to make our mark in the industry and setting the standard for what's acceptable and not acceptable from an engineering standpoint. I don't know if I always do that, but that's what one of our core values are at Whistling Consulting. So let me just bring up my screen. We did put together a PowerPoint presentation, and I'm going to lead the discussion, and then we'll start, seeing who on our team would be able to answer questions here. I don't see my chat with this screen being shared. Actually, I don't have it shared yet. Just let me know when it comes up. All right, you guys able to see my screen?
We are live, yes, sir.
Perfect. Okay, so commercial PV design, right? Actually, let me share a different screen with you. Actually, no, I could pull this over here. One thing, we ask ourselves, why should we be concerned about, solar on commercial buildings? And I do want to give you an example of what is really bad situation from putting solar on the roof or a building, commercial building that necessarily didn't actually support solar, right? So this is in Recife, Brazil. There was an install. This is a church in Brazil where the roof collapsed from having solar put on it. There were 2 people who died in this collapse. And basically was the fact that let me close this. So one of the reasons why we are very concerned, and we all should be concerned about doing solar on commercial buildings, failure, right? We don't want the roof to cave in. When you look at commercial buildings, they typically have different usage categories where there may be more people in these buildings than in a residential home. So very different situation from a liability standpoint and from a damage standpoint if something were to fail here, right? So pretty important that we're aware of what could and could not happen in our applications here, right? So, and we talk about the weight. PV systems can add significant weight to a roof, right? Ballast weights or tilt panels also grab additional wind, which applies uplift and can remove panels from the roof and damage roof systems, right? One thing you need to be very concerned about from a structural standpoint is it's pretty straightforward when you're putting panels on the roof from a residential standpoint. You're going to climb up a ladder. You're going to have the grunt on the job site who's going to be carrying those panels up and placing them somewhere along the edge of the roof, and they're stacking them and they're putting them in piles so that the people who are putting the panels on the roof after you get your connections in and your rails in, and they're going to grab the panels, right? The equipment's going to be placed and staged in specific areas. When you're looking at a roof system from a commercial application, you're now taking pallets of panels, pallets of equipment that get placed on the roof, and you're usually using a crane to do that. Got to be careful where you place those pallets, right? Because now you're looking at a concentrated load as opposed to a uniform load when things are spread out on the roof, and it could significantly damage the roof system and cause a failure if you're putting all the pallets in one spot. There's been several instances where we have had to create a staging plan to identify, okay, if there's a column at this location, you can put a pallet over top of that column because it's going to support the additional load from a point load from a pallet of panels. Whereas you may need to be close to the edge of the roof because there's an exterior wall that will support that additional point load. Very important that we're concerned about those, right? And we take that into account when we're doing our designs. And frankly, there may be some of these existing roofs just frankly may not be designed to handle the additional loads that we're introducing with putting panels on the roof. And that's why one of the important things, site surveys, a lot of instances in the residential market, maybe we can move something forward without having detailed site surveys, but we always want to see what the roof system is and make sure that we're not working with something that's damaged. We know the condition of the roof system. When it comes to these commercial buildings, they're all over the gamut. They could be concrete floors. They could be pre-stressed concrete slabs. It could be a roof system. They could be steel. They could be I-beams with steel purlins. It could be just purlins. They could be wood. They're really all over the gamut. So site survey is super important to have accurate information when you're looking at a commercial application. It's not something that you should just, well, if I could get to it, I could get to it. If not, I'll just force the engineer to approve it without it. It's just not a good idea to do that. And I think there's no way you're going to design the electrical system and the interconnection in a commercial application if you don't have accurate site survey information. And from that standpoint, you've got switchboards capacity could be exceeded, causing catastrophic failure. I mean, array voltage may exceed the rating of the conductor insulation in the warehouse supply. And so these are just really important things to be aware of when you're looking at commercial applications, right? This is an interesting slide, and Heath, would you want to maybe address this slide and talk about some of the codes?
Yeah, thanks, Scott. So a lot of things that we need to look about when we're installing on a commercial structure from a structural standpoint is, depending where you are in the US, the codes are going to change. The codes change probably every 3 or 4 years. They get updated. I think we have some places in Illinois that are still calling out codes from the 90s. And then a lot of places are, into 2018 building code, the 2022 building code and stuff like that. So knowing the correct building code and ASC 7 code is important. It does change the loads and the calculations. Risk category is also important. Designing on a hospital or a school will have different wind loads and seismic factors that go into it than installing on like a warehouse. So those need to be taken into account too. AC 722 is becoming more prominent. Right now, it's only really in Florida and a couple local HJs scattered around the U.S., but it's going to be coming, more to the forefront. One big change on that is the snow loads. So it's kind of embedded into the calculations where it kind of works out to be about the same as what we're doing now. But up front, those snow loads are going to increase by around 30%. And it's going to seem weird that it does that, but it does work out to be around the same by the time calculations are done. But if you're running calculations and some of these ballast reports and other things like your ground mount reports that rely on having accurate snow load information to design the pier spacings, if you're putting in a load from, say, ASC 722, where the snow load's higher, and putting that in, saying you're running it as ASC 716, that's not going to be calculated correctly. So you need to make sure that those are taken into account too. Another big thing that's going to happen is that got brought up to us actually when talking with Iron Ridge not that long ago, is ASC 722 introduces tornado loads, which when you look at the map, it's basically from the Rockies all the way east that's going to be considered. So 2/3 of the U.S. And that's going to be for risk categories 3 and 4. So you're not going to see that on every building. And most likely you're not going to see it because I don't know how many of these installs are usually going on risk category 3s and 4s like hospitals and schools. Normally it's these bigger warehouse type structures. But that will have impacts and increase the wind loads on the panels on those buildings. So different types of buildings to be to take into consideration. Look for pre-engineered metal buildings called PEMBs. We see those a lot. Those are typically designed to about 95% to 100% capacity in its original state because they're very economical design buildings. And, just adding your 3 pounds per square foot of solar can sometimes overstress them. So those need to be taken into extreme consideration, especially if you're going to be putting ballast loads or something like that on there. Other buildings, they might be old that you have to look at specifically that, because they just might not be designed for the codes current. These might be 100-year-old buildings or something that are designed to really no code. So it's always good to have, like Scott said, the site surveys and everything. Going back on the staging and placing a lot of weight on a roof in areas that can't support it, it's really good if you're going to have pallets of equipment placed on a roof to have an engineer review it and design where those need to go, just so you're not putting them in between joists on a metal deck where it's just going to bend and collapse. And the same thing with heavy ballast arrays. If you had seen my example, we have one that came by and I think it was in Houston. And so the wind loads were really high there. And it was saying that it was going to be 16 pounds per square foot, which is a lot of load to place on a roof. So you need to start looking at placing attachments and stuff like that to reduce those weights. One other thing to consider with heavy ballast loads isn't just the vertical force that's being applied. When you're putting that much weight on a roof, you really need to consider the seismic applications too when you're out west or in a high seismic area. So if you want to go to the next slide, Scott.
Yeah. So if you want, Heath, I could talk a little bit about the connections.
Sure.
Well, ballast systems are very popular, and you could see this is a ballast system shown over here on the right. And they're great applications, but there are some things you need to kind of be concerned about. The pros and cons of ballast systems are they can be, there's no connections to the roof, which is probably the biggest pro on these ballast systems because you don't have to do you don't have leaking, you don't have points of connections that wind up being potential for infiltration through the roof system, right? And that's the best thing about it. They come in baskets. and they're usually around a 10-degree slope, which gives you a better angle, better usage on flat roofs. So they really are great when you start putting them on flat roofs. They're easy to install, and they're pretty popular, right? And there's lots of companies that design these. You've got Iron Ridge that has a ballast system, Unirac. Several other companies have really, have lots of variety when you come to these ballast systems. And the blocks are readily available. But the one thing that actually just popped up as we were preparing for this presentation was that there are some situations where if you get a cheap ballast block and it doesn't conform to the ASTM C 1491 and 1884 for moisture, you could actually have that ballast block deteriorate. So something to keep in mind. They do make ballast blocks that are designed for moisture and do not. They're called pressure treated. I think is what they're called, but they're important to make sure you're utilizing those in most of your applications. I mean, when you install it, it's going to be fine, 5 years, 6 years, 7 years, but then it'll start deteriorating if you're not using a good quality ballast block. And sometimes that may increase the price, and that's just something you need to kind of work through, right? There's other types. You have tilt legs, which is on the bottom left. Over here are the tilt legs. Iron Ridge makes a tilt leg that has been fairly popular, and that allows you to get the slope on these flat roofs as well. And then, if it's not a flat roof, or even if it is a flat roof, you still have all of the alternatives between rail systems, connections to the roof, and there's other products out there now. Solar Strap is a product that actually chemically adheres to the surface on the roof, and you may be concerned, and we are as engineers concerned about introducing a uplift load on a roof that maybe wasn't designed for it, the surface. And so Solar Strap even has a process where they actually put a metal screw and a plate down underneath their connection on it. And I believe that Casey Smith from Solar Strap is on the call here today. And Casey, I'll give you a minute or two if you want to shout out your product and tell us a little bit about it if you want to. Are you here, Casey?
Yeah, Casey's on.
Yeah, so if we want to, Ben, if you want to let Casey give us a little bit of background on his Solar Strap.
Just one second here.
Yep.
The Solar Strap, where are you, Casey? So I got the chat blocking you.
Yeah, let's give us a minute on that. If we have to double back to you, are we good to
Allow
go?
me- There you go. We have a lot of registrants today. A lot of
Hey, there we go.
There you are, Casey.
Hey, Scott,
Casey, welcome.
Thanks for having me on, guys. Really appreciate it. Yeah, as you mentioned, so ballast blocks are a big concern in the industry. You mentioned the moisture. Not only moisture, but UV plays a huge role in concrete. So after years, the UV actually breaks it down as well. And I've been in the rooftop game for quite some time, about 15 years. Designed many systems that are on the market, and that is one thing that's never spec'd out, is to have UV and moisture stabilized blocks. So it could become a huge problem. So when we started Solar Strap, we took all that into account, and we actually used a heat welding process to heat weld the system to the roof. And the TPO and PVC roofs, when you actually heat weld, they chemically bond and create a single component. With that, we've done the lifetime testing, all that kind of stuff, to ensure that over a course of 50 years, we only have about 5% degradation in our strength of materials. And that's how we are the only racking system with the ICC number issued to us, and that is based around our patented connection technology. There are others on the market, great things to replace ballast, such as your U-anchors or your OMG power grips. All very great products and ways to reduce weight on the roof. And it is just great for overall building owners to have that less weight for the building structures and upkeep on that. That's one way that we are able to get into most of the larger real estate owned properties. I like to tell people we're always the smallest racking company you've never heard of, but we sell the most out of all the real estate owned properties, I think. And we're in a a lot of your larger cold storage units and everything like that, just because we do reduce that weight on the roof. And they're at like 60, 70 feet typically. So.
Great. Well, thank you, Casey, for a little bit of background on the solar strap. We appreciate that, and we have worked with Casey in projects and have been impressed with what his company has been able to do, as well as several other companies that we work with. Right. So I think covered what I wanted to from a structural perspective. If you guys have questions, again, add them into the chat. But for the sake of time here, we can leave questions towards the end. And I think there is actually, yeah, Aaron, it looks like Aaron Unrich. I think that's how you pronounce it. He did add something into the chat as well, related to the absorption of water. Yep. Yeah, when you have those ballast blocks absorbing water, they increase weight. So not only are you designing it for the ballast load, but if they're going to absorb water, you have to take that into account as well, too. And that's why it's so important to use a block that maybe that is water resistant or able to not absorb water, like we talked about. But thank you, Aaron, for that. And Aaron, I think you are from Iron Ridge, if that's correct, right? You head up their commercial division there. And then Casey Smith. Casey, we just talked about this. Yep, the UV rays as well, too. So let's move over to some of the electrical concerns and do's and don'ts from a commercial perspective. And I'm going to turn the time over to Greg Elvestad. So if you want to talk a little bit about these, and I'll be your Vanna White. You can tell me when to switch slides if you want. Thank you, Greg.
You got that. Okay. Thank you, Scott. Appreciate everybody being on today. Thanks for your participation and attention. One of the things that may or may not be talked about a lot is energy demand versus usage. What in the world are you talking about, Greg? Well, we all know that we design solar arrays keyed off of usage for the most part. What can we do to offset the energy consumption for a given property by sizing an array that can mitigate some, most, or all of the client's kilowatt hour usage? And that's well and good, but there may be a condition where a property is got a certain process going on with a high energy demand for a short period of time, but long enough for it to register on the utility meter as a demand spike for said month, and the billing occurs based off of the highest 15-minute peak for the whole month. Well, why do I care? Well, you could have a beautiful array offset their consumption, but the utility bill might not drop that much, just because in the example on this slide here, they have a $3,799 demand charge for a given month. And that's pretty significant. One of the ways you can mitigate that, and we've got an example of a storage unit here, is battery energy storage. You can bring those on and provide instantaneous peak demand shaving by tapping into the energy that's stored in these batteries to shave the peak off. And there are calculations that would need to be done to factor in the cost of the batteries and the associated equipment to make the interconnection. But if they can dollar out compared to reducing a peak demand from, let's say, $3,800 down to maybe half that, cut it in half at $1,900, scaled out over a period of 5 years, that's a pretty significant savings to go towards the investment of a battery storage device of some sort. Okay, Scott, please go ahead and advance.
How's that? Did I do a good job?
Perfect. Well,
Thank
lovely. You. Interconnection. How can we plug this stuff in? We can do a great job of designing a system, but if we can't plug it in, it doesn't do us any good. It doesn't do the client any good. A couple of examples of old stuff and not so old stuff, but the key point here is, what's the best way to interconnect? We have two options, of course, line side and load side. For commercial properties, where you connect is crucial. You have to have a full, accurate survey, clear photographs done with safety personnel on site to properly expose the busing and switchgear, switchboards, what have you, to assess where a connection can be made. Because at the end of the day, we want to make sure we're making a connection that is code compliant in that we're not modifying a piece of equipment. Because although UL is a great organization, we don't want to have to enlist their services to relist a piece of switchboard or any electrical equipment after we've modified it, and there's a risk that they may not even certify it, and have to spend $6,000 to $10,000 for them to come and evaluate it, only to find out that we can't do what we thought we could do. So that's very, very important to be able to see what's inside door number 1, door number 2, and door number 3. Age of equipment. The bottom photo in this slide is obviously commercial stuff, or it could be light business like a small curio shop, menagerie of different shops in a building. But the bottom line is it's a giant mess. One of the things you want to consider with the age of equipment is, can you get parts for it? The switchboard, even the one on the right here shown, looks in really good condition, but you may not be able to get parts for that. So that's a little bit of legwork and research to be done right out of the gate to be able to try to locate a circuit breaker or a switch, or in some cases, depending on the magnitude of the project, you might even be required to add another service bay, which can add cubic dollars. I know some of our clients are on the phone here today. Some have had some experience with some very horrific expenditures, but age of the equipment is really important. Now, I've been around for 61 years, so I like to say I've been around since dirt was a prototype. But if the service panel is older than me, I'm going to strongly recommend that you replace that. Heck, if it's older than Scott, I'm going to recommend that you replace it.
I didn't think they had electricity back then, Greg.
Well, yeah, that's the thing. But the bottom line is, be careful with what you're walking up to, especially Zinsco or Federal Pacific. I mean, you want to take a sideways glance at those at the very beginning anyway, and maybe consider consulting with the property owner to have that replaced, because you could run into some problem with that equipment. Next thing to consider, system voltage. What are you going to want for your array voltages? A couple of different options out there that I'll leave to Catherine to talk about, but you want to stay at least with your interconnection equipment within the standard utility voltage offerings. So 208 is probably one of the most common commercial voltages. 480 is another one. Sometimes you will run into a condition where you could have 240 delta. Not very common, but you could see it. Be aware of those things and making the interconnections. And if you need assistance on finding equipment for that, consult with a reputable organization to get something identified, so you can at least find something that you can use to get an interconnection made. Another issue related to commercial properties is arc fault studies. Sometimes, depending on the magnitude of a project, there may be arc flash studies as well, which are very expensive studies, and they're not always required, but those are orders of magnitude of 4 to 5 figures in expense, just because of the engineering expertise and the software that's required to do that. But arc fault studies, primarily because you want to make sure that the equipment you're specifying for the project is listed and rated for the appropriate arc fault interrupting capability. I mean, we've got 65K listed here. That's a common size for a lot of commercial properties. In some markets, it can be as low as 22K that you need a study done to make sure that the equipment you're specifying will withstand the fault. It's a very real thing. Why do I care? The condition being a knife switch. Your basic unfused knife switch is only listed at 10,000 amps interrupting capability. And while that may seem like a lot, and it is, when you have a 65,000 amp fault energy capability being delivered to the building, even 100 feet away from the panel, there is the possibility, if there was a fault on the circuit that switch is intended to interrupt, of that fault current being in excess of 10,000 amps. And the last thing you want is for that thing to fail in your hands as you're opening that switch. There's a lot of variables and statistical things that have to fall in place for that to occur. But the bottom line is we don't engineer to what's the probability. We engineer to what can happen. And at the end of the day, that's the only safe way to engineer things, and that's the only way we're going to recommend stuff. Okay, let's proceed on to Scott.
I'm sorry, I'm failing at my job.
Okay. I'll turn over the next slide in the discussion here to Catherine to go ahead and enlighten us on these.
Hello. So electrical concerns, there's a lot to think about on the electrical side besides just the interconnection that Greg covered. We have a lot of things to choose, a lot of equipment to choose, like inverters. And one of the first things you have to think about with inverters is how many do you want? And it's how modular do you want the system to be? It's much easier to install a system with only one or two inverters. But if one or those inverters go down, if you only have one and it goes down, you're completely done. If you have two and one of them goes down, you're half done. But if you put 10 inverters in that system and you have a failure, it's a lot smaller of a concern. But you also have to look at how much space you have to do the installation. Where are you going to put 10 inverters and make those decisions? Another thing to look at when you're looking at inverters is how many maximum power point trackers they have. If you have one big open warehouse roof, you don't have to worry about that at all. You have no orientation differences, no shading or anything like that. But other roofs might be a little more chopped up. Sometimes the architect that built the building wasn't necessarily thinking about solar when he made the roof, and there's a lot of different roof faces going different directions. And you will have to consider how many MPPTs each inverter has, because you can't have modules on the same maximum power point tracker facing different directions. That will not work very well. It will produce power, but it will not produce power efficiently. The other thing about the maximum power point tracking that you have to take into consideration is the lower voltage on the maximum power point tracker. A lot of times an inverter has a very low start voltage, but it won't efficiently do the maximum power point tracking at that low voltage. So while it will work, it will not work at its most efficient state. If you look at the data sheet, it'll often show, rated MPP voltage, and that starts as high as 500 in some cases. So stringing more panels together will allow that inverter to get the higher voltage it needs to work more efficiently. So as we're talking about DC input voltage, you also want to look at the maximum DC input voltage on the inverter. Pretty much every commercial inverter out there now is 1000 volt rated at least, but some of them are 1500 volts DC, which may not be right for your application. So you have to look at that. If you're doing a carport, it's great. If you're doing a building roof, it's not exactly desirable. So looking at what the DC input voltage is very important. And also looking at the AC output voltage is very important. And as I'll get to in a minute, you don't necessarily want to match the voltage of the existing system. So let's talk about that as we talk about conductors. Choosing wire is actually a big deal. Wire is very expensive. Choosing which wire can really make a difference in your budget. And if it's a short wire run, it's not a big deal. But sometimes you have to get from one end of the building to the other with your conductors, and then suddenly it matters. We do have to use copper conductors when we're dealing with the DC power on these systems, but once you get to AC, you can use aluminum. And people tend to not think about aluminum because you have to use bigger wire when you're using aluminum, but it still can be a lot cheaper than copper. I was talking to a contractor just the other day, and talking to him about copper versus aluminum. He said, "Oh, it'll be bigger, it'll be more expensive." And I said, "No, take a look." And he looked, and it was over $1 a foot less to use aluminum conductors versus the copper conductors, even though they were bigger. So with the copper prices as they are, definitely something to consider. Voltage drop is something to be concerned about. If your runs are more than a few hundred feet, you could run into voltage drop issues and have to upsize your wire larger than you would need just for the amps that's flowing through it. It's something that can be calculated easily. It's just something that you have to be aware of. A lot of people who aren't used to working on such large buildings don't think about those longer runs, don't realize that you have to upsize the wire for those longer runs. And again, with the copper versus aluminum, a lot of people have it in their heads that they shouldn't use aluminum if there's a voltage drop problem, because aluminum does not handle voltage drop as well as copper. But in the end, again, you'll have to go higher, bigger wire with the aluminum, but it still might be cheaper than using the copper. As far as the voltages go, we were just talking about the AC voltage of the system. If you're working on a 208 volt system that the building has, that doesn't necessarily mean that you should choose a 208 volt inverter. If you have a longer wire run, it often makes sense to choose 480 volt inverters, or even the larger ones that do 600 volts or 800 volts, and step that down with a transformer. And the reason why you would do that is for voltage drop. So if you can use much smaller conductors over a several 100-foot wire run, and then buy a transformer to drop the voltage at the end, that often makes more sense than going with 208 volt inverters and really large wires running from wherever your inverters are to where your main service panel is. Another thing with the conductors that a lot of contractors don't realize if they're not used to working with three-phase is the inverters are balanced systems. So the neutral conductor is only for reference, which means you can put in a smaller one. In some cases, you can skip the neutral conductor entirely. So that can also save you a lot of money if you're aware of that difference. Another thing we have to talk about is equipment locations. We have to be very careful with all our clearances. We have to make sure that like our AC disconnects are where the fire and utility company can get to them and the fire department can get to them. And we also have to look at, when we're deciding where to put equipment, the conductor cost. Again, if you put your combiners closer or further away based on whether it's going to be better to run a lot of smaller wires or less larger wires, you have to factor that in. And oftentimes just doing a little bit of extra time on the calculations will save you a ton of money in your costs. Another thing to factor in when you're looking at equipment locations is operations and maintenance. There's nothing more fun than climbing up and down a ladder in an arc fault suit, trying to measure DC voltages on DC combiner boxes on a carport that are way high up in the air. So think about these things. Think about the accessibility of the equipment to someone who's actually going to have to work on it later. So those are all the things that we would consider. Well, not all the things, but many of the things we would consider. There's a lot more to it, but we're running out of time. So I'm going to hand this back over to Scott.
Thank you, Catherine and Greg. Appreciate your insight when it comes to electrical. And I don't want to take a lot of your time, so I think we're gonna wrap this up and open it up for some questions. Right, just in closing, on our end, what's super important, you can tell that there's a team right here that can help you with your projects, right? And that's what's important, is you need to have professionals who can help you, or you need to work with a company that has done a lot of commercial designs and has experience with a lot of the electrical concerns and the structural concerns. I mean, everybody wants to do the right thing, and maybe there's times when maybe we're trying to cut some corners to save some time, and in the end, it may not be the best way to proceed. So again, whether you're using Whistling Consulting, it's important to have a team that you select that has experience in doing it right, and making sure that that they walk you through the process. Now, you know, since we've been doing commercial designs and engineering in-house, which we started about a year ago, there's been a real need for a team like we have to be able to have a kickoff meeting. You know, typically it's important to have a goals meeting to start off with, to talk about your interconnections, to talk about the equipment selection, to talk about concerns related to the roof system and have that kickoff meeting sometimes can save thousands, if not tens of thousands of dollars when you're just walking through inverters and transformers and wire sizes and type of wire. These are all things that your team should be talking about up front. Don't think it's the best idea to send designs overseas to someone who doesn't really understand anything about our local codes or doesn't have electrical engineering background or structural background to be able to do your designs, unless you are 100% confident that you can review those plans and make sure that they're accurate and showing what you need to be shown on there. So I'm going to close. I appreciate, again, everybody's time that you took to be on this call. It is super cool. We have 35 people on this call. I'd have to say that this is the most we've had on one of our webinars. I'm extremely pleased with everybody's willingness to participate. I do want to give a couple minutes for those of you who are on the call who have experience in the industry. Like, I know we have a couple people from Iron Ridge that are on the call, and we had Casey chat a little bit with Solar Strap. And if there's any other manufacturers, if you wouldn't mind, just take a minute to tell us a little bit about who you are and maybe some insights that you guys have in your process that may be helpful for the group. And again, this is not any manufacturer specific. We're not trying to do that. These calls are supposed to be ones that we're all trying to help each other as a team working in the solar business and solar industry to make a good product and have things safe for our customers and our client base. So I'm going to stop sharing my screen and open this up now to questions and answers. And yeah, I'm going to turn the time back over to Ben. If you want to coordinate that would be great.
Absolutely. Thanks, Scott. Yeah, if you guys can just raise your hand, I'll go ahead and I'll unmute you so that you can ask the question that you have.
Glenn's got one up first right away there, Ben.
I was looking for Glenn. Where is he?
I might be able to turn him on. I can see him here. Allow mic. Okay, I think you should be good to go, Glenn.
There you are, Glenn.
Awesome. Thank you very much. Just wanted to quickly introduce Iron Ridge. I'm Glenn Woodruff. I'm a product marketing manager. And Aaron Unruh is on the call, who's our commercial services director. And, we have a dedicated team. So we have also tools like our design assistant where you can, go in and design a system and get a bill of material. But we just want to be a resource like Whistling is, and, appreciate you guys having us on in the background.
Thank you, Glenn. And Aaron, I think I may have butchered your name earlier, but Aaron, if you are in charge of commercial design, is there something that we've missed that maybe you might want to add from your insight from a commercial perspective when you guys are starting to look at these commercial accounts?
No, hi. I don't think you guys missed anything. I think it was a great presentation. Really, respect the call to action to verify and to validate the structures before moving forward with your design work in whatever tool you're using or whichever product you're using. I wouldn't mind going back to some of the ballast comments. That's my forte. I've been in commercial solar, working for different manufacturers since 2011, with a very strong focus on low slope ballasted application. So the only things I would say is that if we go back to that, some of the comments on the ballast block, I totally concur. As you could see by my comments, the ballast block is critical for selecting the correct net compressive strength is really what it comes down to, with the spec for most companies coming in at 3,000 PSI. Over the course of my career, I've generally maintained that 5,000 plus is always the way to go. And that's usually under a freeze thaw application, not necessarily required in California, but still great for nailing down the exact dead load and preventing additional water absorption. And going a little further, I noticed that the ballast plan picture there was for 16 PSF. That's extremely high, where ballast usually comes in around 5 PSF, 5 to 6 PSF. I just completed a project at 2.4 PSF I think it's important to know that all of the ballast manufacturers out there actually have the option to use attachments to offset that load, all the way down to 0 ballast blocks, as is seen in other applications. And it's quite safe. It's been something that we've done for quite a long time now. If you take it back to Europe, we're in the 30-year range, and the practices are only getting better. They're all based on wind tunnel tests versus code prescription, which is where you find most of your design loads and requirements coming for non-ballasted applications, which are, of course, just created by the code body based on experience versus empirical data, was what you get with the wind tunnel test. So yeah, that's about all I wanted to add here, but I am definitely a resource for anybody on the call. Again, this has been my bread and butter for about 12 or 13 years now. Happy to help however I can. And when we do offer design services, consultation, and feasibility conversations on a daily basis for commercial projects of all sizes.
Yeah, that's great, Aaron. I'm fine with whatever information you want to put into the chat, an email or number, whatever you want to do. That's fine, so that everybody on the call has it. And Aaron, thank you for identifying. I forgot to talk a little bit about some of the weights of ballast systems and that you can connect it to the roof. Whistling Consulting, we typically want to limit, and the reason why we have that into the slide was for me to talk about the fact that we had a 15.99 pounds per square foot on the ballast, which is probably not something that we would want to see, right? But we had it in there so that I could talk about it. We typically limit them between 5 and 6 pounds per square foot for ballast, simply because a lot of these buildings, like Heath had talked about, we want to kind of minimize what the loading is on them, because when they were built, if they were built over 20 years ago or even 15 years ago, odds are they probably weren't taking into account a 15-pound miscellaneous loading on the roof, right? They do take in miscellaneous loading. Yep, they do take miscellaneous loading into effect from like utilities, like HVAC and electrical. They do that, but I don't think they really would be designing something to take a 16-pound per square foot. So we internally try and limit it to 5 or 6. And the way you limit the weight is just what Aaron said. You put connectors. So you can design a system. Unirac and Iron Ridge both have calculators online that you can go in and you can design a system, and you can specify if you want to use connections or not, limit what your total load, what the maximum load you want to have per square foot. And that's really what I would recommend when you guys are looking at doing these ballast systems. And it sounds like Aaron's a good resource for that as well, too. But yeah, thank you, Aaron.
Absolutely.
Were there any other questions? I see, Glenn, you have your hand raised. I don't know if it's from the previous question or if you have a new one.
I have one before Glenn hops in. I didn't hear any comments on UL 3741. What's the whistling stance on?
It's a great segue. I was going to bring that up, Glenn, and I forgot to. Forgive me for that.
You're on mute, Greg.
You got me.
Sure, I just muted myself and I thought I was live. Okay.
So
when possible,
that's everything that Greg has to talk about on UL 3741.
When possible. No, seriously, it's a great point. Thanks for bringing that up, Glenn. We want to try to engineer to 3741 compliance as much as possible. So we will work with you on that to look for compliant racking and hardware to meet that. Because if you can avoid having to have module level electronics on a 1,000 module design, that's some serious coin to avoid spending. So we want to be able to go down that road, because you've got engineered systems that are compliant with 3741. And for those that are unaware of what that is, it is system engineering compliant as a package to meet the challenges of rapid shutdown requirements. So there are specifics about how you bond everything, where you mount the inverters. They have to be in very close proximity to the arrays, so they will be within a few feet of the arrays on the rooftop. And I'm gonna tag Catherine on that as well to feed into this conversation. Thanks, Aaron. Yeah, they had to be right beside the array, and so we can design that, but that also has to factor into how it gets installed on the rooftop to provide for a means of mounting that. So there may be an additional attachment or two for unistrut or rigid pipe or some mechanism, advanced tilt or something like that to get the inverters as tight to the array as possible to be compliant with that. Any other thoughts out there? I'll throw that open for a second.
Yeah, I'll just throw out the major distinction between the traditional way of capturing the rapid shutdown requirements is to reduce voltage within the array boundary within a certain timeline. And the major difference here is that we're actually testing complete solutions. So from down to your wire clips and your cables and your conduit, every piece is listed, just like a refrigerator UL listing would be, or any other components in your home. And the major change, which Iron Ridge pioneered this listing with the BX ballasted solution because it is a polymer-based solution. Ultimately, we were under the impression that an insulated solution would perform better because the goal of UL 3741 is to ensure that the for an energized system at any given time, the potential for shock hazard is low based on the current or the amperage rating of any destruction of piece of equipment within. So rather than reducing the voltage, which unfortunately was never substantiated as a life-saving practice, we're just ensuring that at any given time, say a firefighter on the roof fighting a fire who falls into a module doesn't experience more than 4 milliamps of current, and therefore does not experience shock hazard.
Thanks, Aaron. Okay, I don't want to keep you guys too much longer. We're just about at a little bit below before the 1 hour mark. Is there any other questions or anybody who just wanted to say hi and give a shout out on the call or anything like that? Is there anybody who has a desire to ask any other questions or Daniel?
Your mic is live, Dan. Go for it.
I figured I'll pop in. I could definitely confirm that what Greg and Scott and Heath, what they all confirm when it comes to projects, especially dealing with old jobs here in California, they definitely know their items and will verify with it. And then if you're doing a system, and your gut says like if you're first going and surveying it, go bother Scott and make sure that roof system's gonna work. It's definitely something that you want to make sure so you don't have what happened with that church down in Brazil.
Yeah, absolutely.
Yeah, and I'll tag a little thing on the UL 3741 because of where I'm located. California, particularly most of the majority of the jobs that we deal with have 1 million roof obstructions. So if you could utilize it, it will be amazing. And then when you do, make sure you look at, as Aaron was talking about, like each little component, and especially verifying with the inverter manufacturers how their take as well. Because like if a Solar Edge or Solus is going to have a different take than SMA versus another string inverter company, and dealing with obstructions and all that, and going on and off, having one portion with the UL 3741 and one with ML or modular power level electronics. It's just definitely double check and verify everything on that. It could be a headache, or if your sales guys love to sell nice open roofs, or if you're not in California, great. Well, kudos to you and enjoy.
Thank you, Daniel.
I could add to that. In that,
go ahead. Sorry.
The missing piece there for sort of satellite arrays or those that are broken up as a result of obstructions currently is only written into the listing. However, the equipment doesn't exist. We see examples of it with like the Tesla Powerwall in the residential market, where they have a string isolation device that allows you to install subarrays outside the boundary. I'd expect that in the commercial space, that's available before the end of next year. From any of the given listed inverter manufacturers, so that you are allowed to use a single or multiple string isolation devices in order to incorporate the satellite or subarrays into that original string arrays portion of the UL 3741 requirement. So hopefully next year we'll have a solution to that, Daniel.
Thanks, Aaron. And Daniel, thanks for the plug. Actually, Daniel's one of our customers. Why don't you give a shout out? A shout out.
I see how
for
you
your
think of
company?
me. I
From New
see.
Jersey, man. He's from New Jersey.
I apologize. Strike that from the record. But Daniel, if you want to give a shout out again, tell me what company you're from.
The
Sorry.
best day of my
Yeah.
life.
Yeah, so I'm with IE Construction or Integrated Energy Group, depending on the name that it goes under. We do majority of like new construction with commercial here in California. We work with a few other states, and then we also do a large amount of new construction residential projects. So that's kind of like our bread and butter when it goes on there. And so I've been working with Scott and Greg for about almost 3 years now. So that's why I was able to, say, yeah, they definitely know what they're doing. And then
Well, thank you.
Aaron, to add on for the 3741, there is actually we've done a couple installs to where if we're utilizing like a solo string inverter, where we've installed just MLPE on a certain array that had breakups and stuff on there. So, and then there was another section that met all the requirements. So unfortunately, like that instead of having that single string isolation device or being able to extend it, like that entire array had to have MLPE on the entire thing and all the strings. So there
Absolutely,
is
yeah.
a couple, but it'll be wonderful once that, especially for residential projects, when that mythical unicorn is what I heard at the NABCEP conference will come
It's
out.
available for residential for Iron Ridge, both through Tesla Powerwall. We're the only one with the primary listing up to 600 volts, which will allow you to reduce your MCI connections. And then also, Glenn, correct me if I'm wrong, Solus also has a string isolation device so that for the most part, homeowners don't want the inverter on the rooftop, right?
Midnight Solar has the
Midnight.
device.
Midnight
It's
for
associated
Solus, right?
with, Solus inverters.
Right. Yeah. But I question for you, Daniel, you still found some cost savings, I suppose, in the portions of the arrays that you were not required to install module level rapid
Oh, yeah.
shutdown? Yeah.
Definitely. I mean, you're talking about their like pricing's about $40 to $80, depending on what model or so you're running. When you have a few thousand panels up on a roof, it's a significant cost savings.
In fact, we
Yeah.
Oh, go ahead. Sorry.
Oh, I was gonna say, we were working on one project that we're proposing it, and it was a few $100,000 in savings potentially if we versus going with like 3741 and a Solus inverter versus like a Solar Edge, which our one particular client preferred. It was insane, the difference in cost.
We estimate that it's roughly 6 to 12 cents a watt for the MLPE units cost to customer, and then roughly 15% of the mechanical install. In other words, strapping, mounting them to the module or to the racking, and even before wiring. So cost of labor plus that 6 to 12 cents, you're looking at easily overtaking the cost of the racking in the first place.
All right, guys, I'm going to jump in here. We're just about at our hour mark. I see a lot of people jumping off. I believe that people have certain time frames that they want to have on these meetings. I don't want to go too much longer, but hey, great discussion. I super appreciative of everybody hopping on and taking time out of your day. I hope this was helpful. We are going to be doing these on a monthly basis, so we'll sending emails out to you guys. If you have anybody you want us to add onto an email list who gets these invites, you're more than welcome to either reach out to Ben Peterson directly or even drop some information into this chat if you want to. But again, we're grateful for all of you guys, especially for our customers and suppliers here, manufacturers who make everybody's lives easier in the industry. And anyway, thank you so much for your participation, and have a great day. Thank you.
Thank you for having me. Yeah, it was
Thanks,
excellent.
guys.
Thank you.
Take care.